There is a number that cannot be written, not because it is too large, not because it is forbidden, but because it never ends. It goes on past the last digit you could ever record, past the last moment of your life, past the heat death of every star, and still it continues. That number governs the circle. It governs the orbit of every planet. It governs the curve of every wave that has ever broken against every shore since the beginning of the world. And somewhere in the 3rd century of the Common Era, in a land most Western mathematicians would not study for another 1,000 years, a man sat alone with a stylus and a counting board, and he decided to chase it. He did not know he would never catch it. He went anyway. His name was Liu Hui. We do not know when he was born. We do not know what he looked like. We do not know whether he had a family, whether he had students, whether anyone read his work in his own lifetime and understood what he had done. What we know is this. In the year 263 of the Common Era, during the turbulent reign of the Three Kingdoms period in China, Liu Hui wrote a commentary on an ancient mathematical text called The 9 Chapters on the Mathematical Art. And within that commentary, almost as a digression, almost as a footnote to someone else's work, he solved a problem that had haunted mathematicians for centuries. He solved it so completely, so elegantly, and so far ahead of his time that the world would not catch up for nearly 1,400 years. And yet say his name in any room, watch the silence that follows. We speak of Pythagoras. We speak of Euclid. We speak of Archimedes. These names have been wrapped in legend, pressed into school books, carved into institutional stone. They have become synonymous with the very idea of mathematical genius. Liu Hui has not. This is not an accident of history. It is a tragedy of it. The 3rd century was a time of war and political fracture in China. The Han dynasty had collapsed. Kingdoms rose and fell within generations. In that climate of instability, a scholar who worked quietly, who built no school, who sought no court appointment for his ideas, such a man could do extraordinary work and vanish entirely into the noise of a broken age. And Liu Hui vanished. Not from the universe, not from truth, only from memory. For as long as human beings have drawn circles, they have wanted to understand them, not just to see them, to measure them, to know the precise relationship between a circle's width and the distance around its edge. This ratio, what we now call pi, was known to be slightly larger than 3. Ancient Babylonian scribes estimated it at 3 1/8. Egyptian mathematicians, working from practical geometry, came close enough for construction. The Bible, in the Book of Kings, casually implies it is exactly 3, a statement that is wrong, but forgivably so. Archimedes, that towering Greek mind, understood that the true value could be bounded. He inscribed a polygon inside a circle and circumscribed another polygon outside it. The circle's circumference had to lie between the two. He calculated using 96-sided polygons and determined that pi lay between 22/7 and 223/71, a result of remarkable precision for a man working without algebra, without calculus, and without anything beyond compass, straight edge, and the force of his own reasoning. This was considered, for many centuries, essentially the end of the matter. But Liu Hui was not satisfied with essentially. He looked at what Archimedes had done, and he looked further. Begin with a circle. Now inscribe a square inside it. 4 sides, 4 corners touching the edge. The square is smaller than the circle. Its perimeter is shorter than the circumference. But it is a beginning. Now double the sides. 8 sides. An octagon. It fits the circle more closely. Its perimeter grows nearer to the true circumference. 16 sides. 32. 64. With each doubling, the gap between the polygon and the circle narrows. The shape grows more circular. The perimeter approaches the circumference like a whisper, drawing closer to a truth it cannot quite speak aloud. This was Liu Hui's method, and it was more than a technique. It was a philosophy. He understood, without the formal language that would not exist for another 14 centuries, that what he was doing was approaching a limit, that the polygon could never become the circle, that each step would have the remaining error but never eliminated, that the target was real but the arrival was impossible. He continued anyway. 96 sides, 192, 3072. By the time Liu Hui reached a polygon of 3072 sides, the shape was, to any eye that could see it, indistinguishable from a circle. The gap between the two had become invisible, theoretical, infinitesimal, and still he knew it was there. That is what separates Liu Hui from a craftsman. A craftsman stops when the error becomes too small to matter. A mathematician continues because the error always matters, not for practical purposes, but for the purposes of truth. He was not building a wheel. He was not calculating the area of a field. He was doing something far stranger and far more beautiful. He was thinking about what it means to approach something you can never reach. He was thinking about infinity. He had no word for it, no formal framework, no tradition in which such thinking had been sanctioned. He was working in the dark, with nothing but the cold light of his own reasoning. And it was enough. Liu Hui arrived at a value of pi of 3.141592, correct to 5 decimal places. Let that sit for a moment. Correct to 5 decimal places. In the 3rd century, without modern notation, without algebra as we know it, without the concept of a decimal point as a formal system, working by hand, on a counting board, in a fractured kingdom, in a language that would not be read by European mathematicians for over 1,000 years. He then went further. He proved why his method worked. He did not merely claim a result, he constructed a logical architecture around it, demonstrating that as the number of sides increased, the area of the polygon grew closer to the area of the circle in a predictable, bounded, demonstrable way. This was not estimation. This was proof. And when he finished, he set it down in his commentary and moved on. No announcement, no ceremony, no audience applauding from the steps of an academy. The scroll was copied. The copy was copied. And the name of Liu Hui drifted slowly into the margins of history, where it would wait patient as the number it had chased for someone to notice what had been accomplished there, in that silence, in that 3rd century room. In 1687, Isaac Newton published his Principia. In it, he deployed with unprecedented formal precision the machinery of what we now call calculus, the ability to find exact values by means of infinite processes, the ability to arrive at truth by describing the path toward it rather than the destination. Leibniz developed the same ideas independently, around the same decade, and the two men spent years disputing priority. Neither of them was first, not in the spirit of the thing, not in the intuition that lies beneath the formal machinery. Liu Hui had understood, 14 centuries before Newton was born, that you could find exact mathematical truth by constructing an infinite sequence of approximations, that the truth was the limit toward which the sequence converged, that you could reason about that limit with perfect rigor, even if you could never compute it directly. This is the central insight of calculus. Liu Hui did not formalize it the way Newton and Leibniz would. He did not have the notation, the algebraic framework, the centuries of accumulated mathematical language that they could draw upon. He was working in a tradition that had its own extraordinary sophistication, but was developing along different lines. What he had was the intuition, raw, unmediated, breathtaking in its reach, that infinity could be tamed, not by conquering it, but by understanding how you move toward it. He was not a precursor to calculus. He was not a lesser version of Newton. He was a mind that arrived at a neighboring truth by its own independent path, through its own independent genius. And he did it alone. In the 3rd century, in a kingdom at war, there is something almost unbearable in Liu Hui's method, and I do not mean that as a criticism. I mean it as a recognition. To know that you are approaching the truth, To know that each step brings you closer. To know, simultaneously and with absolute certainty, that you will never arrive and to keep going anyway. This is not a failure of method. It is the nature of infinity itself. Pi cannot be written down, not because we lack the paper, but because the paper would have to be infinite. The number goes on without pattern, without repetition, without end. It is not irrational in the colloquial sense, it is irrational in the precise mathematical sense, meaning it cannot be expressed as any ratio of whole numbers. It is transcendental, meaning it cannot be the solution to any polynomial equation with rational coefficients. It is, in a very real sense, beyond language, beyond notation, beyond any finite system of representation. And Liu Hui spent his life drawing as close to it as a human being, armed only with reason and time, could draw. There is a spiritual register to this, if you allow yourself to hear it. The idea that truth exists beyond our ability to possess it, that the pursuit itself is meaningful, even perhaps especially when arrival is impossible. That each step toward the infinite is worth taking, not because you will reach the end, but because the step is true. Liu Hui was not a mystic. He was a mathematician. But the mathematics itself becomes something close to meditation when you look at it long enough. 64 sides, 128, 256. Each one a confession. I am not there yet. Each one a commitment. I am going anyway. This is what it looks like to love truth without condition. Liu Hui did not know what would happen to his work. He could not have imagined that his commentary would survive the collapse of the three kingdoms, the rise and fall of dynasties, the long centuries during which the mathematical traditions of East and West developed in near total isolation from each other. He could not have known that, 1,500 years after his death, mathematicians in Europe would independently rediscover the ideas he had already worked through and receive, in that rediscovery, the full credit of history. He could not have known that his name would one day be spoken in this way with the recognition it deserves, or something approaching it. He simply worked, and the work was true. That is perhaps the most disquieting thing about Liu Hui, not that he was forgotten, but that the forgetting did not change anything. The mathematics was correct, whether anyone knew it or not. Pi continued to be pi. The limit continued to exist. Truth does not require an audience. But we do. We require the knowledge that what we do matters, that what we discover will outlast us, that the loneliness of a mind working at the edge of the known world is not an accident, but a calling, and that someone, someday, will understand. So here is the question that Liu Hui's life leaves behind, quiet and unresolved. Who is working in silence right now? Whose counting board sits in a room no one enters? Whose proof is buried in a language no one reads? Whose polygon grows closer and closer to a circle that will one day have their name attached to it, but not yet? What truths exist today, fully formed, waiting in the dark? We will not know until someone, centuries from now, finds the scroll. And when they do, when they finally read what was there all along, let them ask, as we are asking now, why did it take us so long to look?